All right, let's take a look at the tutorial 6 homework here. We had to implement this simple stack interface to this stack container. Now, before we get started, it's good to, to have a plan, right? Be on the same page. So, first off, I told you to watch the video if you haven't already on the stack. I give you a link to a little snippet there of the stack and how a stack can work. The concept of a stack. The basic idea is you push values onto a stack like this. You would push a value, let's say you push 5, and then you push 3, and then you push 69. Your stack is going to look like this. That's the push operation. It'll push a value onto the top of the stack. It keeps going up. Now the other operation is pop. Pop will return the top value of the stack, so that'll return 6, and then it will remove that from the stack. So if I pop, I will get the value 6. If I pop again, I will get the value 3. And again, if I pop, I will get the value 5. So that's the idea of a stack. Now the other thing is, I told you have to implement this with a linked list. So again, I briefly talked about linked lists in a previous video, but let's get into a little more depth. I expected you to hopefully do some research on your own, figure out what a linked list is, how one might implement such a thing. But the basic idea is it uses pointers, right? So let's say we've got our stack, and it's got a pointer p top. So this will point to the top element of the stack, and then this will be a stack element, and it is going to have a p next, and it will point to the next element of the stack. So this is the top of the stack. This is the second from top, and again we have another element. Beautiful handwriting there, and it's obviously got a p next, and it is going to point, well, if the stack only has 2 elements, this one would point to null pointer, and that would be the bottom of the stack would then be here. So this is the basic idea of a stack. Now the operations, how will we implement them with the stack operations with a linked list? Well, let's look at the push operation. All a push will do is you will create a new element. So we'll just call this one L, and it's got a P next. So you create a new element. You're going to make that element point to the current top of the stack, and then you're going to make P top now point to the new top of the stack. So it'll look like this. This is what a push operation will look like. So what does a pop operation looks like? Well, I mean, first off, each of these elements, I forgot to put it in here, but they all have a value, an integer value, right? That's the actual thing that's on the stack. So they've all got a value. When you want to pop one off the stack, what I would do is, there's a few ways you could do it, but the general idea is you copy out the value to some temp. Then you maybe get a temporary pointer, so p temp, I don't know, to the top. Then you make this one point to here, the second from top. So you make it point to whatever top was pointing to. So you basically copy this pointer value into here. Now it's pointing to previously the second element, now the top element. So now you've got this set up correctly. Now you can break this, maybe set this guy to null pointer, and then you can delete this, and there you go. Now you're all set up. You've just popped the top off the stack. You can return this temporary value, and your stack is now in the proper setting after popping. So lots of bullshit operations there. Linked lists, they're kind of a pain in the ass to handle, but it's a good exercise as a programmer to mess around with this shit as well. Get some of this experience under your fucking belt, brah. So that's the general ideas. There's some other operations, specifically size, and the way we'll do that is we will count recursively. So we'll do a recursive counting function. This guy will count this one will return 1, this one will return 1 plus 1 is 2, this one will return, well, that's it. That's the end. So the count will be 2. You'll see when I do the code. So yeah, we're going to implement this bullshit here. Let's just build it. You'll see that the compiling works fine, but we hit the link error because none of these functions are implemented. So what are we going to need? Well, first off, we're going to need a class that is going to be our element. So we'll create an element class. And now we're going to need the pointer to top. So element pointer p top, and we make sure that it starts off with null pointer. All right, now to push an element on here, we want to do a whole bunch of shit. What we want to do when we're pushing an element is we got to create a new element. We got to make that element point to the current top, and then we've got to make the current top, or the p top, now point to our new element. So what we can do is we can create a constructor for element that takes a pointer. So we'll go public, now private. So element is going to have an element pointer to p next, set those initially to null pointer, and it is going to have, I guess I'll put this at top, it's going to have int value. That's the payload value that is going to be held. That's what's actually going on the conceptual stack. So element, and we're going to construct an element with an int value and an element pointer to p next. And the idea here is, I believe we can just go value, val, and p next, p next. So this will allow us to construct an element, giving it its next pointer and its value to store. Now with push, all we need to do is we need to do what? I guess we need to create the new element. So we go, let me think here. We can do p top is equal to new element and the value and p top. And so that will set the new element to point to whatever p top is currently pointing to. It could be null pointer, it could be the current top of the stack. And then the p top will now point to the new element. So that'll work. That's for pushing. Now for popping is going to be a little more complicated. So let's go int temp value is equal to, we need a function to get the value. So let's go int get val const return val. Well, there we go. So temp val, we'll make this one const as well. Why not? Why not make it constant? TNT, it's dynamite. No, let's do that. Let's go. All right, so we're popping off the top. First thing we should do is we should make sure we have an element on the top. If our thing is empty, then we're going to have problems. So if not empty. So if we're not empty, then temp val is going to be p top pointer to get val. Right? And that's the first thing we do. So we get the temporary value. Then what we do is, let me think here. So what I want to do is I want to create a function that disconnects an element from the linked list. What this function is going to do, essentially, is it is going to take the element that is to be disconnected. It is going to set its pointer to null pointer. So now it's no longer part of the link, and it is going to, as a return value, it is going to return whatever that pointer was previously pointing to. And that is, we're going to call that function disconnect. So element pointer disconnect. And we are going to do auto p temp is equal to p next. And then we're going to do p next is equal to null pointer. And then we're going to return p temp. So this will disconnect and return whatever it was pointing to. What we're going to do with this is we're going to go const auto p old top is equal to, no wait, that's not right. Yeah, we'll do p old top is equal to p top. So there's our old top. Don't make it const, make it just normal pointer. So now we remember our old top. Now we do p top is equal to p top pointer to disconnect. So this will disconnect the current top element from whatever it's pointing to, and it will return that pointer so that our p top can now point to it. So the idea here is that we disconnect it here, we break this connection, and now we return this pointer here, so now p top is going to be pointing to here. That's making it ripe for deletion. So now this guy is completely disconnected from the linked list structure. And we've already stored its value for temporary storage. So now we can go delete p old top. And then we can return temp val. And there you go. You have your pop operation if our structure isn't empty. If it is empty, we just want to return -1. That is going to be the signal that the pop failed. It's not perfect because obviously this thing could also contain -1 as its value. But it's fine. It's fine for this exercise. Normally we'd use something called exceptions here. But it's fine. It's fine. So pop, push, size. Now size is interesting. We're going to use recursion for this. So let's create a function int count elements. And it's const. And what it does is if p next is not equal to null pointer, then we're going to return p next pointer to count elements plus 1 for the current element. Otherwise, if this is the last element in the linked list, we'll just return 1. So this will add up all of the elements recursively going down the chain of links, and it will return that sum. And then for size, we can do return, well, first off, again, if not empty, return p-top pointer to count elements. Else, return 0, because if we're empty, obviously we're going to return 0. And empty, let's just keep it simple. Return p-top is equal to null pointer. So I mean, if p-top is null pointer, that means we've got an empty stack, so return true. And there you go, we have implemented all of the things. Now we're going to have a few problems here, but let's run and see what we get. All right, read access violation break. So obviously this isn't enough. Size, yeah. Okay, so we've got problems here. We failed test 6. Now, the reason for this is because, let me go back to stack here. First off, we're not really motherfucking handling the situation with the copy constructor and the assignment, the copy assignment. And we got to do that. Otherwise, you're going to have the bad situation I was talking about before. You're going to have, things trying to delete stuff twice, accessing memory that no longer exists, all sorts of dumb bullshit. So what we got to do is we have to go element, const, element, and source. Now, remember what I told you before? Remember I told you that you can implement the copy assignment and then use that in the copy constructor. So that's what we're going to do. We're going to go... No, this was dumb. It's not element, it's stack. First of all, it is stack. That is stack. So we need to do what? We need to return stack reference operator equals const stack ampersand source. Now, what are we going to do? Well, this is a tricky one because we've got to do a deep copy. We got to do a deep copy of a linked list. Now, as you can see here, linked lists tend to work very nicely with recursion. So what we want to do is we want to do a deep copy of our linked list with recursion. And I'm going to show you how we do that. Let's create another constructor for an element. We're going to create a copy constructor. So const element ampersand source. And it's going to be recursive. So what it's going to do is, first of all, it is going to copy the value. So val source.val. Second thing it's going to do is it's going to check if source.pnext is not equal to null pointer. So if this element has further elements down the chain, we also want to deep copy those elements. So what we do is, if that is true, then we go what? We go pnext is equal to new element, and we'll call the copy constructor with source.pnext. So this will allow us to recursively deep copy all of the elements in a linked list chain. Then, for this, all we've got to do is go if not source.empty p top is equal to new element star source dot p top. And there you go. So if we're copying, if we're copy assigning a non-empty thing, we're going to do a deep copy on all the elements starting from the top one and going down recursively. This is where the beauty of recursion comes in. Now, like I said, we can use that for this. All we got to do for our copy constructor is we go this equal to source, and that will invoke the copy assignment operator and do our work for us. Now this works, but we don't have default constructor anymore, so let's go stack equal to default. And I think that should do her for our shit. No, wait. Oh yeah, I made the same mistake I always make. Stop it. I always make this goddamn mistake. Let me see the output. No, that's not what I wanted to see. That is not what I wanted to see. So they make the same mistake that I always make. I forget to return this pointer for the operator. There we go. Let's try it. All right, there you go. We've passed all the tests, but in this testing logic here, I've also added some memory leak checking logic. So let me just see if I can't get, yeah, there we go, get this fucker all drawn up. So we detected memory leaks. We have detected a whole shitload of memory leaks, and that makes actually a lot of sense. You can see there's a whole bunch of blocks that have been leaked. They're all 8 bytes long. And you'd think that makes sense since our elements, which are the things that are being constructed on the heap, they are also 8 bytes. 4 bytes for an int, 4 bytes for a pointer in x86 mode. So, of course, yeah, makes sense. We're fucking not deleting any of these elements. So we need to set some destructors. Now, one destructor I'm going to make is a recursive destructor. We're here. So I'm going to go element. And the recursive destructor is going to delete p next. And for safe measure, we'll set p next equal to null pointer. So destroying an element causes all the elements down the chain to also be destroyed, which is safe. Now all we got to do for our stack destructor is destroy the top element, and that will recursively destroy all of them. So we go tilde stack. Fuck. Hate that bullshit. And we go delete p top equal to null pointer. And there you go. That should prevent our memory from being leaked. And there you go. We've passed all the tests and we are not leaking any memory any longer. Hey guys, it's Future Chili here to tell you that I may have fucked it a little bit. And you might be saying, Chili, I don't get it. I mean, all the tests pass. You don't get any memory leak warnings. Seems good. But the problem is, I didn't make first of all, I didn't make the tests as robust as they should have been. So I'm just going to copy this test here. I'm going to paste it out here. We're going to call it test 9. And test 9, what it's going to do is it's going to push some stuff onto stack S. We're going to create S2, and then we're going to push something onto S2. Push. I don't really care what it is. At this point, I'm just fucking pissed that I didn't catch this in the beginning. So yeah, it's always a good idea to make your tests as rigorous as possible, because if we put our fucking 9 in here, now we get, oh, good, happy days. Let's just, yeah, there we go. Detected memory leaks, dumping objects. So we have a memory leak. So how does this happen? How could this happen to me? Well, if we look here at this test, what is it doing different than the test we copied from? We're adding something to S2 before we assign to it. And that's a big hint as to what the fuck is wrong here. So let's take a look at what happens in the assignment code. And we'll go into stack.h. And in the assignment code here, we're assigning ptop to new element, calling the constructor recursively, which is good, except what happens if ptop was already pointing to something? For example, what if it was already pointing to an element that contained this value here that we just pushed onto the stack? Well, that memory, my friend, is going to be leaked, and we can easily prove this. If I just add another one in here, I'll just change the value somewhat, and I'll run that motherfucker. And here you go. Now we've got 2 objects that have been leaked. And if we look in here, we can see that these values correspond to the values that we pushed onto the stack S2. So that's a problem. How do we fix it? Very simple. All we got to do is we got to check to see. Well, if not source is equal to empty, yeah, that makes sense. So if not empty, if we are not empty, then we're going to have to go ptop. We're going to have to delete ptop. That'll recursively delete it. And we don't have to do this, but it's always a good idea to just set the null pointer. And that's not going to hurt. It's not going to cost you fuck all, and it's good practice. So if we're not empty, delete what we've already got. Then if the source isn't empty, do a deep copy. Yeah, that's the ticket. All right, now if we run this, now all the tests pass, and this time it is for reals, except, of course I fucked it up with the renaming of that thing. All right, I'll rename it. Where is it? Test 9 passed, test 9 failed. There you Here we go. All right, so there you go. Now it should look all good, except for my fucking capture software, which hates me. But anyways, so yeah, a little bit of fuck up there, but we fixed it. This is Future Chili signing off. And there you have it. There's how you implement a container in C++ with proper, rule of 3, obeying your memory allocation bullshits. Couple of things. First of all, you might have had some troubles debugging because when you debug, and let's say you trip some kind of exception like I did before, you're going to get sent to this code here and you're not going to know what it is. And you might say, well, that's bullshit, Chili. I don't know what any of this code is. You're making me debug shit that I haven't made. But here's the deal with that. Think about this. If you're doing a programming challenge, you're going to have a bunch of tests and you're not even going to be able to debug them. It'll just tell you the test failed and that's it. So you get even less information. So sometimes you gotta suck it up and just figure it out. Either by staring at your code and trying to figure out why it's causing a failure, or by stepping through this and trying to understand these test cases. But either way, you're going to have to do it. The worst thing you could do is when you get an error, just assume, it's got to be some error in Chili's code. It's not my code, it's Chili's code. And if you make that assumption, it's very dumb. It doesn't mean that it's impossible for that to be the case. But usually when you get errors in programming, it's because you fucked up. And if you have the mindset of trying to blame someone else as your first answer, that's a terrible mindset to have as a programmer. You're not going to make it far. So that's one thing. Second thing I want to say is that memory leak detection, if you want to use that in your programs for debugging purposes, all you got to do is you include these 3 lines at the top of your main CPP file or whatever. You include these ones, and then at the very end, before you leave the program, you call CRT dump memory leaks. And that will dump them to somewhere. Now you can set where they are being dumped to with these functions. Set report mode, set report file. I set them to all dump to the console. Std error defaults to going to the console. But you can set them to go in other places. And if you want more info, you can, look this up. You can Google this function name. I think you know on how to use Google by now. You can Google the function names, figure out how they work. But it's a useful tool that helps sometimes if you want to, make sure you're not leaking any memory. But yeah, that's it. That was the assignment. I hope you got it. I hope you were able to do some research on your own and figure out what a linked list is and how you might implement it. And I hope you were able to implement the RAII rule of 3 bullshit and pass all the tests and leak no memory. And if you were able to do that, then congratulations. If you weren't able to do that, don't worry about it. You can't win them all. But hopefully after watching this video, you now understand the errors of your ways. And it might even be worth it now to start again from 0 and try to code it up on your own just to make sure you've got this shit down. If you fail and then you watch the video and you see the answer, you should probably go back and now try to implement that yourself. Don't just assume, I saw the answer now, I understand. It's a good chance that you don't yet understand until you've done it all yourself from 0. But I'll leave that to you. It's all up to your responsibility. I can lead the horse to water, but I can't not make him drink. Anyways, hope you enjoyed me teaching you some C++ bullshit. If you did, click the like button, whatever, it's all good. And I will see you soon with some more C++.